Science Genie again on the show. In this video, we will be doing your alkanes, your alkenes, and your alkynes. So now, your alkanes are your saturated hydrocarbons having a general formula of CnH2n plus 2, where n can start at 1, meaning that when you substitute your n here, you can start with 1, meaning that you can have your alkanes having 1 carbon over there. As you can see, we have our methane, and then another one would be your ethane, your propane, and this kind of molecules right here, whereby you'll be having your branches. So notice again, all of these guys, when we name them, they are going to have a suffix of ane, right? So that's going to be the suffix, it's going to be "ane". So now let us check if this general formula actually works for all of these molecules. So let's have methane right here. So methane has how many carbons? It has C, and it's 1. And then how many carbons? How many hydrogens, I mean? It's 1, 2, 3, 4. So it's H4. So basically, if you write it, it would be just CH4. So does it work with the general formula? So the general formula is CnH2n plus 2. So if you substitute a 1 here and you substitute a 1 here, it would give you this number. Just like 2 times 1 is 2, and then you add another 2, it gives you the 4. So now it does work for methane. So let's check if it works for ethane. So your ethane right here, we know the general formula is CnH2n plus 2, and then now it was going to be C2. As you see, there are 2 carbon atoms, and then it's H 2 times 2 plus 2, meaning that now it has to be C2H6. So now let's count the number of hydrogens: 1, 2, 3, 4, 5, yes, and the 6. So now the general formula does work for this one. So let us check if the general formula works for this one here at the bottom. So here it is going to be CnH2n plus 2. How many carbon atoms do we have in 2-methyl butane? So it's going to be 1, 2, 3, 4, and then it's 5. So it's going to be C5. And then how many hydrogens do we have? It has to be 2 times 2, which is 6, plus 2 and 12. So do we have 12 hydrogens? So let's count together: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So indeed, we do have your 12 of your hydrogens over there. So that's what's happening there with your alkanes. Basically, they are going to be having single bonds between carbon and carbon atoms. And then let us move on to your alkenes. So now when it comes to your alkenes, the alkenes have a general formula of CnH2n, right? And then now let us check here for ethene, right? So basically we say that here your n has to start from 2, because now we identify your alkenes by having a double bond between carbon and carbon atoms, and you can't have a double bond between one carbon atoms. Like, bro, how can that happen? So now basically here we have to start from 2. So here it's C2, and then it's gonna be H. If we say 2 times 2 over here, this gives us C2H4 according to the general formula. So as you can see, there are 2 carbons, and then there are 4 of your hydrogens. So it works for your ethene, right? And then we have this molecule right here, which is your propene. So your propene, if you have the general formula, it is CnH2n, and then how many carbons do you have? 1, 2, 3. So it's C3, and then it has to be H2 times the 3, which is giving us C3H6. So how many hydrogens do you have over here? So the number of hydrogens is 1, 2, 3, 4, 5, 6. So that is what is happening over there. And then now when it comes to this molecule here at the bottom, so here at the bottom we have what? We have 3-methyl but-1-ene, we will be covering naming in the other videos. So now let's check if the general formula works for this one. So as you say, the general formula is CnH2n. Apologies for that. So it is CnH2n, right? So CnH2n. And then now, how many carbons do you have here? So we have 1, 2, 3, 4, and then 5. So it's 5 carbons, and then it means that the number of hydrogen has to be double that. So now it has to be C5H10. So let us count the number of hydrogens that we are having there. So the number of the hydrogens, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So indeed, this general formula works for your alkenes. And then notice again, guys, when you are having an additional bond or an extra bond in the general formula, let's look at alkanes. Alkanes, you have one less bond between carbon and carbon atoms, so it becomes CnH2n plus 2. So you remove one bond, you add two hydrogens, you add one bond. It means now what do? You remove those two hydrogens, then now it's gonna be CnH2n. So you're gonna see that it's gonna be the same thing for your alkynes basically there as we move to your alkyne. The alkynes here, they have a general formula of CnH2n minus 2. Wow, what's happening now? It's CnH2n minus 2, as we just spoke about it right now. And then how do you identify your alkynes? Your alkynes have a triple bond between carbon and carbon atoms. So now you see that you add one bond, you subtract two hydrogens from your hydrocarbon molecules. You add one bond between carbon atoms, you subtract two hydrogens. So that is basically what is going to happen over here. And then let us check if the general formula works. So here the general formula is CnH2n minus 2. How many carbons do you have? 1, 2. So it has to be C2. And then obviously the carbons always have to be starting from 2 in the molecules. And then now it's gonna be H 2 times 2 minus 2. So now 2 times 2 is 4, minus 2, that's 2. So it's C2H2. As you can see here, we're having two hydrogens. So let us see if it works for these other molecules. So we have here propine, and then as we have propine, it is going to be what? It is going to be C3, and then we have to say H 2 times 3 minus 2. So then it is what? C3. And then we say 2 times 3 is 6 minus 2, that's 4. So then now you see you have 3 carbons and you have 4 of your hydrogens. Right. So let us do this last one for the show, and then we move on to your other of the homologous series. So we have but-2-ine here. As I said, here your 2 is gonna be indicating the position of your double bond or your triple bond, but that will be covered in the other video when we are doing naming. So here in but-2-ine, we have what? We have how many carbons? 1, 2, 3, 4 carbons. So it is 4 carbons. And then now, according to the general formula, we have to say 2 times 4 minus 2. So 2 times 4 is 8, minus 2 is 6. So it's C4H6. So do we have 6 hydrogens? Let us count. 1, 2, 3, 4, 5, and 6. So indeed we do have 6 hydrogens, and that is it for your alkynes. Notice again that for your alkynes, your suffix will be what? Will be YNE, YNE, YNE. It is also in the name, just as your alkenes, you're gonna have ENE, it's also in the name. So that's an easy way to remember your suffix, because it is a suffix of the homologous series basically. Then as you move to the next video, I thank you guys over there.